So when you are going to do that, you are going to write something like that. Given, these are the data given to you, right? Then you are going to say, is that? This should be your R. What is the value?
44.29, sir.
Is it?
Ja, das ist half the answer for the parallel.
How much you got?
44.3 or 44.28, sir.
So this one is 44.285. Right?
Yes,
Step one, you got that?
yes, sir.
Everybody? No. No. What is this no? This is 44, 44.285.
It's our
How?
total.
It's the internal.
So you take the.
We got, okay, so, so step one, you know this one, right? This one is okay? Now we are going to make the parallel combination of these two. When two resistances are parallel, how do we do that? R1 times R2 divided by R1 plus R2. So this is the parallel combination R1 times R2 divided by R1 plus R2. Clear? So this is that resistance and this is this. So you are going to add this one to that. So this one is the 30 plus this one. Now do it in your calculator and see you get it or not. 20 times 50 divided by 20 plus 50. Right? Then result, then plus 30. Got it? Everybody?
And this and the parallel.
Everybody?
And also the different work processes after that.
If you have any question, let me know. Yes.
Sir, it said that news I one that we created in the second circuit.
Now we are going there now. Let's do this one first. This one, anybody, any question here? No. So we get the value of R is 44.285. Clear? Now we are going to go to step 2. Do the step 2. Step 2, you remember how the circuit will look like? Is it step 2? So we are keeping the resistances, load is removed, and the battery is there, right? Now let's take a loop like that. Clear? Let's take this one to be I1. Okay? Now write the equation, loop equation. So if you start from here, so it will be 50 I1, drop means minus. Clear? So minus 50 I1. Now going that direction. So the current is going that direction, right? And you are also walking from here. You are literally walking, right? The drop is 50 I1 minus 50 I1, and here also you are along the direction of the current. Clear? So this is also minus 50, minus 20, minus 20 I1, right? And then you are going from there to there, from negative polarity to positive polarity, that is voltage rise, that is plus. So plus 20 should be equal to 0, that is your loop equation. So we are doing it mesh analysis. Where? KVL, we are applying KVL here in this loop.
Yes.
Now you need to find out the value of I1. So I1 equal to how much? 20 divided by 70, 2 by 7, is it that? Is it that?
Yeah.
Any
for some-
question here? I knew you were going to ask something, eh?
Niet
So
vanaf
what's the next
Hij
step?
heeft wel gezet plus
Going for the
20.
next step. So this
Ja,
one
dus
equal
dit nou net
to
die result van minus 50
0.2.
I1.
Ja, of bij plus 20.
Is dat plus
Six.
20? Is
Ja.
gelijk aan 0. Ja,
Is it-
want hij
We
20
are
komt
getting
van die
0.2857,
batterij
we are
af.
taking 0.286. That is, we are taking 3 decimal places. Clear? So this is your I1. Right? Now we need to find out. Any question here?
Yes.
So we are applying mesh analysis. KVL. We are applying mesh analysis here. Clear? Now we are going to.
Sir,
Yes.
how do you know the direction of the resistance? Because you found out that it's minus 50.
So why do we take minus 50 I1?
Yeah.
So whenever we are doing that, we assume the direction of current. So we have assumed the direction of current to be this one, right? You can assume the other way around as well. You will have different equations, but the final answer will be same. So we are assuming this way. So I1 is going in that direction. Now we are walking from here. So if we walk along the direction of the current, that will be drop. Here also we are going along the direction of the current.
Yes, like how do you know that we walking along the resistance?
How do we know we are moving along the direction of the current?
Yeah.
This is the direction of the current. If
And
you
the
walk from there to there, are you
resistance
along the
is
direction or
like
are you along the direction or against the direction?
the resistance, is it going like
So
this
sit
or
basis
like
maar
this?
net loop 1 I1.
No, we have already assumed the current is flowing this way. Current is flowing this way,
Yeah.
right? We have assumed. The answer might be different. That's not a problem. Whatever we have assumed, we are going to write the equation on that basis.
Okay.
Final answer, if the assumed direction is wrong, then the answer will be negative, meaning I1 will be negative. Then actual direction will be this direction. That doesn't matter. So either you get positive I1 or negative I1. If you take this direction I1, if we get here, is positive as per the equation.
Meaning
If,
Die begin
let me finish. If you take in this
plus
way,
20 plus 50.
you will have I1 same value but negative value. Meaning you say the current was flowing from there to there, right? But actually current is flowing from there to there. So that's why you got negative current. Whenever a current flows from there to there, if you go this way, this is positive direction. If you say no, current was flowing this direction, then your answer will be negative.
Okay.
Is it clear or what is your question?
Yeah, like meaning if I found a current negative, that means
It will be opposite to your assumed direction.
okay.
Clear?
Dus het mij
Oké.
zo. Oké.
And
Dan zit hem zo uit. Sorry.
any other question?
Nee.
No. Okay.
Dus het is
So
de afgelimiteerd. Plus 20.
now we need to find out the
Niet al
drop
plus 20. Precies zo.
here. Right? Now if we work from there to there,
Minus 20 plus 20.
we have to find out VAB.
Zo nou.
Okay? We have to find out VAB. But the thing is, if you need to find out V of A with respect to B,
50
now
in
tell me
20
whether you will
plus
walk from A
20
to
van
B
die
or
boxen
you will walk from B
staan.
to A.
Oké. Nou, wat je doet is je vanaf 20 weer. Nee. Dan
If
zit,
you
dan
need
zit
to find
minus
out
70
VAB,
aan.
are you
is
going to
gelijk
start
aan
walking
minus
from
20.
A to B or B
Dan
to
gaat
A?
je die 70 uur onder dus die
A to B.
eindelijk is gelijk aan iets. Is gelijk aan 20.
Okay. If you say that, let's do it and we will see if we have any
Ik heb
problems.
ons 20 uur gevraagd. Dus
Okay, so we need to find out
soms weer. En dan gaat je
VAB.
minus
Clear?
70 uur.
The best way,
Minus 20
the
uur,
best
minus
way of
70
doing
dan
it
was het
is we are going to take the value. We need to find out VAB, right? So say this one here, this one here is VAB. Does it make sense? Yes. Now, we can have a loop equation here. We can have a loop equation here. So in that case, doesn't matter which direction you start. We have VAB here. We need to find out, right? Now, doesn't matter if you start here or if you start there. But let's start from here. If we start from here, what is the drop here? 0. What is the drop here? 50 I1. 50 times I1, right? And then we go there.
Oh ja.
And then in order to finish the loop, this one is going from here. It is voltage rise or this one is voltage rise or drop? Voltage rise, that is positive. So VAB, so let's write, that will be easier. Let's write a loop equation for this one.
Oké.
So we take VAB here and it will remove all the confusion. So we are going to write a loop equation there starting from A, right? So it would be 0 times 30 minus, right? It doesn't matter, 0 is plus or minus, this is drop. Then minus 50 I1, right? This is also drop. Plus VAB equal to 0. Does it make any sense? Yes. We need to find out VAB. So VAB equal to 50 times I1, that is 50 times 2 by 7 to be accurate, and that would be 100 by 7. And what is that? 14 point?
14.286.
So 14.286 volts. And VAB is obviously positive here. Voltage rise. Clear? Any question? So that is the Thevenin's equivalent voltage.
Met Gairi. Ja, kijk. So die stroom hier loopt zo. Minus 30. Ja, meer dan maar als het al current was. Denk ik. Minus 30, ja.
Okay, I'll again explain voltage drop and rise.
En dan
I'll
is
explain that.
plus.
So this one, can we go to step 3 now? So step 3 would be the equivalent circuit. this is your A, this is your B, and this one was 100 ohm, and that resistance was 44.285, and that voltage was 14.286. This is plus, this is minus, right? And this is your load resistance. So basically this is this part is the Thevenin's equivalent circuit. Clear? So you write the Thevenin's equivalent resistance, you write the Thevenin's equivalent voltage, and as for that one, we said this is small r, and we said this one to be E, right? This one is E. But mostly what we do, we say Thevenin's voltage, we say V Thevenin, right? And for Thevenin's resistance, we say R Thevenin, something like that. And the other resistance, we say RL, load resistance. So V Thevenin, Thevenin's voltage, R Thevenin, that is Thevenin's resistance, this one and that one, and this one is load resistance. Clear? So the current, you need to find out the current here. This current is I. The formula is V Thevenin divided by R Thevenin plus load resistance. Clear? So V Thevenin we got how much? 14.286. R Thevenin is 44.285. And RL is 100. Is it that?
Sure.
Clear? And what is this value? How much you got? 0.099 ampere. Is that?
Yes, sir.
So you can say 99 milliampere, right? Okay, coming. Does it make any sense?
Yes, sir.
Here, one caution, in case you get the value of V Thevenin, we got 14.286, it could be negative as well. If you get the answer negative, meaning the direction of the final current would be the other way around. Meaning, here instead of plus, E will write here other way around. Clear? Meaning the direction of the current will be other side. Yes? There was a question. Yes.
This I that we just worked out, would that be your I Thevenin?
No. So better to remove the confusion, better you said IL, load current.
Yeah.
You write this one to be IL.
And IAB was the current source.
IAB. IAB is the IL. That is the final answer we're looking for. Clear? Any question? Quickly do another one, and then it will be much more clear. Yes.
0.3 ounces. This guy, the IAB is 1.3 ounces. That's automatic.
I cannot hear you.
Yeah. It's only something. It's only something that ström i en strömgas. Så.
Come here.
Ja. Dus gewoon zie je se 4 A B. Dat is like een 5 daar.
So which circuit you are looking at?
Mal I. Ja.
Can you hear here?
För I die something.
Yeah, go there. Tell me the question then. Where is the question? Yes. Yeah. Yes.
But the minute into the spiritual voltage,
Yes.
like shouldn't account for the current that is
Yes. Question, okay. The question is not yet clear. Let me understand the question. But you said this I1, direction of I1, and that at that direction. What happened here? Somebody threw something here. Right? Where is that one? This one.
Yes, sir.
Is anybody left mechatronics? Can you come and take it from here? And right, so he had a question that we took I1 here, right? There was a direction, and then we took some direction here. So the confusion coming this direction and this direction, right? Yes.
So mis ek basies maar net dan weet ek.
So his question is Kirchhoff's or Kirchhoff, whatever you say, Kirchhoff's current law. So at that point, what will happen about this current? The question is now clear. So this current here should be the combination of this current and that current. But there is no current. I'm answering your question. You said if we apply Kirchhoff's current law, one current will come from here, that one, and one current will come from here. This current is 0. So 0 plus I1 is I1. There was no current here. That's why it still remains I1. You are right. If there would be another current, that current would be identical. But here there is no current 0, so this is 0, 0 plus I1, so this current remains I1. Clear? Okay. Any other question? Yes. Volume.
Voltage rise. Nee, voltage drop. Voltage drop en saam met die current.
The voltage VAB.
Voltage.
Which voltage?
Das is hier voltage.
This one.
Hierdie en as dit voltage rise.
Which one?
Saam met current. Ja, en sal wel
VAB.
as voltage rise. So dan hier so net.
This voltage.
Voltage rise.
So what is the question? How do you know the voltage?
So ons het voltage rise teen die current en voltage drop.
Quick, we need to go to the next.
So, kijk, hij moest nou zo. Zij gaan negative, positive. En hij kan zo op, zo hij is tegen elkaar en zo zwaait. Ja.
So kry jy né? Want ons het nou so ombeweeg. Ja. Dus ons nou so ombeweeg.
The question
Voltage
is,
drop, voltage drop,
yeah, the
voltage
question,
rise.
how do you know the voltage will right here, the direction, whether it is right or not?
Want dit is klaar aangedui dat dit op rise is. Dit is klaar dit aangedui. Want jy kan dit ook tegnies gaan uitwerk as jy sê die stroom wat soontoe loop is 0. Ja, maar hier kan dalk nog 'n stroom deur soontoe loop as dit die path of least resistance wil follow. Dan kan dit dalk ook iets soos 'n 5.
Hulle het hom klaar aangedui dat dit wel is.
Ja.
En die kyk, hoe werk die mens uit wat kan ons nou weer loop.
We explained this one already, we are going to re-explain that one, eh? Voltage drop and rise. Do you have another question?
Kyk, ek het dit nou net weer gaan kyk.
Keep the question in your head or write it down on your page and then I'll come back. So, now, we are dealing with voltage drop and rise in two cases. One is current flowing through a resistance, and the other one is we are having a battery, right? The first one is, say you have a resistance like that. The point is A here, the point is B here, right? The current flowing through this one is I, the resistance here is R, okay? Now you would like to work, I'm trying to find out if I have any red pen. So this is the direction of the current. Now you are walking along that direction. Okay, you are walking. Right? So what is in that case, you are walking along the direction of the current.
Yes, sir.
Right? So that would be
Drop,
Drop. So this one is drop,
which is negative.
right?
Yes, sir.
And the value would be IR, right?
Yeah.
And our convention is drop is negative.
Yes.
So this one is negative.
Yes, sir.
Clear?
Yes, sir.
Yes or no?
Yes, sir.
And if we go the other direction, I don't think I have any clue. No. Anyway, so if you go the other direction, so you are walking electrical, anybody left? Come here. So if you go this way, right, again you are walking. That one would be against the direction of the current, that is rise. Okay? That is IR,
Meer voltage.
and this one would be positive.
Yes, sir.
Clear?
Yes, sir.
So this is all about the voltage drop and rise.
So daar is
When you are
aangeduid dat
doing,
dit
you are dealing with the current and
This one
resistance.
is onion
Okay?
place.
And now, if you have a battery,
Verstaan jy? So dit al aangeduid dis 'n rise. In die current vloei so
okay? So this point is A,
en ons loop
this
so.
point is B, this is plus, this is minus.
Gaan dan current connections
So if you go that value is a E.
Dis
If you
gaan
go that direction,
die ene gaan in ag.
right?
Ja.
You are walking along this.
Yes.
This one is drop or rise. This one is drop, that is minus E. Okay? And if you are walking that direction, so this one would be rise because you are going from negative to positive, and that is plus E. Clear?
Yes, sir.
So this is your, so this is all about the battery, and this one is your clear? So our assumption is, we are assuming drop is negative and rise is positive. Clear? Any other question? No. You have a question? I answered it.
Sir?
Go.
Sorry, sir. Can you just keep it on the board that I can quickly just write it down? Just the last one, the battery one, please.
This one.
Yes, please. Thank you.
Okay, we are going to go for another one. And this one would be little. When you finishing? 9:30.
Yes.
Can you not extend the time?
No, so we have
It's
close
too little, eh? It's too little. Because I don't want to go like a bullet train, eh? And that will be difficult, that is, if you go like that. All will be boundary. You are watching cricket today? No? All will be boundary. So anyway, nothing will go there. It's done?
Yes, thank you.
And we are going for another one. And let me quickly go there. Sorry. Yes.
Ja, zo. Ik heb gekozen in die kant, maar het verdraait.
Yes, Baba Saki. Don't worry, just draw a circuit.
Don't worry, just do the circuit.
We are not applying Kirchhoff's law here. We are applying only Thevenin's. Let's see. Let's see. The resistance of the various arms and so on and so forth. The battery has like that. And the negligible resistance determines the value and direction of the current is PET. Go.
Encouragement op zijn tot zijn beste.
Yes or no?
No,
Quick. Quick.
betekent dit niet zo snel. Nee, wat.
But I can promise you, if you learn Thevenin's theorem right, then Norton will be much easier. Is it a distress call or what? Is it a distress call? I suggest not to draw the currents direction, only the circuit. But if you have done it, don't worry. You can redraw that, that's fine. A, B, C, D, 10, 30, 15, 20 and 40 ohm. We need to find out the current IBD, right? We need to find out the current IBD. Clear? Have you done it? Yes or no? It's too late. Too late now. Quickly check whether my figures and the circuit is right. A, B, C, D, 10, 30, 15, 20 and 40 and the voltage is 2. Voltage is 2, right?
Alright. That's fucking
We don't like that. Let's make it 20 volt. Let's make it 20 volt. Okay. Ready?
Hier begin ik focus.
So what we need to do, whatever we are going to say is given. Everything is given. We need to find out. Yes, sir.
Meneer de Reef.
Yes, sir.
Dat is
Meneer.
We need to find out IBD, right? By Thevenin's theorem. Clear? So this is your Thevenin's theorem. We need to find out IBD. Let's go to step 1. In order to do that, I need to little bit zoom out. Can you see still? Okay. Right? What is step 1? You remember what we did? Step 1. What we are doing? We are finding out R Thevenin equal to how much? This is your step 1, right? We are finding out R Thevenin. Clear? In order to do that, what we'll do? We will remove the load resistance. That is 40 ohm will go. Okay? And also we are going to replace the battery by internal resistance, right? Yes. Let's do it. So again we are going to draw so in this one you need to draw quite a number of times the circuit and don't be lazy. That will not help you at all. So this is 10, this is 30, 15 and 20. This point is B and this point is D. We need to find out R Thevenin. R Thevenin is what? R Thevenin is the resistance across B and D when it is open circuit. Clear? That's what we do. Okay. Don't watch the movie, eh? You also write. Okay? Now what we are going to do, we need to, okay. Now tell me, this point A and this was A and B, right? Now tell me what is happening between A and
C.
A and C. What is happening between A and C?
No one knows.
What is happening there? What is happening between A and C?
It's a series.
A boy is sitting at A girl is sitting at C, and they are getting short circuited. Is that A and C are coming together, just like this one. Is it that? If there is no resistance, so A and C are short circuited, meaning instead of putting the line here, we can put a line here. Right? And then we can shorten the line, they will come together. Does it make sense? So meaning, let me draw it this way. Just to get a little bit more clarity, it would be something like that. So these two are here, this is 10, this is 30, this is 20, and this is 15, right? This one is B, and this one is D. Does it make any sense? Now you sort these two one, meaning you remove this one and you put them together. Meaning, so this is the equivalent circuit here, right? And what will be the further equivalent one? So that's why I said you need to draw quite a number of circuits. Don't be lazy. So this one, what we can do, we need to find out this one. And even that one also, we can have a line here as well. We can say this is B, and we can say this one is D. Can you do that? Can you do that? What we did, the B was this point. We are saying B is here. Just a line, there is no resistance. Just a line, there is no resistance. So we are going to state B and D. We are going to separate B and D, but we are going to merge A and C. Okay? Clear or not? No. Meaning there was a relation between that and is broken, and D1 is started. Clear? No. You do it every day. Anyway, so what we are going to do,
I just spoke
we are going to do B is here, right? And we are drawing like that. Tell me if I am right or I am stepping, I am jumping the step. If we say like that, if you feel a little bit overwhelmed, then I need to redraw that. So this is your B, this is your D, this is your 10, this is your 30, this is your 20, and this is your 15. You see that?
You also did.
This is the relation between B and D already broken, and the relation between A and C is restarted or started. So this point here, basically this point, we can say this point, all the point is basically A and C. So this side we can say this is A, this is C. All these points A and C are joined together. Clear? Question? If there is a question, then I am no. Yes. Yes. First of all, let me explain what I have done. Then probably you get the answer there. Okay, this is a circle, right? And it did not have any problem from going to there, from there to there, right? Now what we are doing, this was a triangle, right? And what we have done, this also is a kind of triangle. Meaning point B, we have stretched the point B. For B is here, B is here, B is here, B is there. We have stretched B a bit. So meaning we have taken this like that, and we are taking the resistance down there, and we are putting this one. Forget about this bit. Forget about this. What we are doing, we are taking this line here like this. We are doing the resistance down there, and that's what we did. Yes? And the same thing we did from the bottom side as well. From the bottom side as well. And then we join that. So say if this one is A or C, whatever this one is A or C, so then you get two parallel there in series. So we wanted to make a series parallel combination, and that's what we got. Still you have the question? Not in this way. Can you probably, is there anyone who can give me a better way of doing this one? I mean, the understanding will be much better. Can you draw it in some other way?
I think it's solid.
Okay, do it, and we'll take it up. So if we could have done it a little bit better way, what would be the better way? It could be something like that. If we, instead of doing this, if we would have tried to do like this one, say, okay, let us do it. How is it helping? It's not helping at all, but anyway.
Die maak je meeste sin.
So then, this one is B, this one is D. So this is 10, this is 30, this is 20, and this is 15. Does it make any sense? So instead of doing that, we could have probably done this way. Does it make any sense? So meaning these points, these are basically A and C. So we are merging A and C together. We are merging, what we are doing, we are taking these two together and merging this A and C. So top side is one triangle, kind of not triangle, it was a diamond, and the bottom side is another triangle. Does it make any sense? Yeah or not? Is it yeah? Is it clear? So we go from there to there and we go from there to there. The more you practice, the number of steps will be reduced. Right? So here, if you need, you can go from here to there and from there to there. The more you practice, the more you get the idea, then you can bypass everything. Yeah? So now, so what we are getting, clear? Yeah. Now, I have only 16 minutes. Okay. So,
Je kan niet zeggen 10, want je kan niet zeggen
so it will
1
look
op
like,
10 plus 1 op 30 is die
so we have,
1 op
we are still step 1, eh?
30. Dus
So we have B here,
je kan zeggen
and we can now say there is one resistance, and there is
liever zo snel
another resistance. So this is B, this is A and C, and this is D. So this is the combination of 20 times 15, 20 plus 15. I could have jumped that step, but I am keeping here for better understanding. And this one is 20 times 30, sorry, 10 times 30, 10 plus 30. Right? So what is this value and what is that value?
Top one is 7.5 is the first one, sir.
300 divided by 40, 7.5. It's a good figure. And
8.571.
by 35, 8.571.
571, sir.
Okay? Clear?
Yes, sir.
So we got it from the previous one, then the next one what would be? The next one would be something like that. We'll have a simple resistance B and D. And this one is RBD, which is basically your Thevenin. Clear?
Yes, sir.
And that value is what?
16.071, sir.
So 7.5 plus 8.571. 16.071,
071.
is it?
71, sir. 71, sir.
What I did? 7.5 plus 8.571. 16.071 I am getting.
Yes, sir.
So this is your
Thevenin.
Thevenin. Clear? Step 1 is done. So now we are going to step 2.
Yeah.
Anyone, any objection here?
No, sir.
No? Okay, let's go to step 2. And you have your circuit there, eh? And I also have here. I'm going to go for step 2. That one would be pretty easy. Step 2 here would be, I guess it would be easy. That one, and don't forget to label ABCD here. These are important. You get that one, and what you get. And you have the battery. Okay, let it be as it is to minimize complications. So this is 20. Is it that? 10, 30, 20, 15. Any question? Step 2, we need to find out what? We need to find out, step 2, we need to find out V Thevenin equal to V B D equal to how much, right? We need to find, this is step 2. Clear? Right. Now we are going to apply what? Mesh analysis. Okay? So in the mesh analysis, I am assuming like that, I don't know what you want to do. This one is I1, right? And then another one is there. We are going to take another loop like that. This is your I2. Does it make any sense?
Yes, sir.
So there is one loop there. This is one loop. And that one is another loop. Okay? So we are going to write the equation straight, and you guys know it. So I don't want to kill time here. So it should be, we are starting at point 8.
Nee, met 5
Clear?
die I1.
10 I1 positive or negative?
Negatief.
Then 30 I1 positive or negative?
Negatief.
Okay, then to be honest, we are not applying mesh analysis exactly, but yeah. So in mesh analysis, what we do, where the I1 is flowing, we just add up all the resistance. Don't we do that?
Yeah.
We do that. So in I1, 10 plus 30 plus 15 plus 20. So I am going to erase that because I don't have a pencil. You guys are not using pencil, right? So I am going to write like that. So minus I1 times 10 plus 30 plus 15 plus 20. Clear? Can you see the zero or not?
Yes, sir.
Okay. Now, I2 is flowing in the other direction. So we are working like that. And I2, you see, it is opposite direction. I2 is also here opposite direction. So it will be plus I2 times 20 plus 15 equal to 0. Clear or not?
No, and then add 20 still, so
What else is there?
the 20 volts.
No.
Why must we add?
We are in the loop 1. We are not in loop 2. Confusion, right? Okay. So we are doing what we are doing here. We are doing this one, right? So 10 I1, 30 I1, 15 I1, 20 I1, all are negative. We are in the same direction. But remember, these two resistances are there through which another current is flowing, I2. So this I2 is going that direction, this I2 is going that direction. So when we are considering this loop, I2 is flowing from there to there. But we are traveling this way. So that is opposite one. That is voltage rise. That is I2 times 15 plus 20. Clear?
Yes, sir.
Yes. Yeah, so I am walking like that. So along the I1, but these two resistances have another current, I2. I2 is flowing this way.
Yes, sir.
If we consider branch currents, right? This one will have I1 this direction, I2 that direction. Or this one I1 this direction, I2 this direction. Don't forget that. Clear?
Yes, sir.
So okay. And what is the equation 2? We are starting from here, right? So again, that one will say that is drop minus I2 times 20 plus 15, right?
Yes, sir.
Plus I1 times 20 plus 15, right? Plus 20 equal to 0. There are a lot of questions, I guess. Is it?
Sir?
So here, yes.
I think to complicate it, you must just put brackets around it just to show the guys that's part of loop 1 and the bottom one is still part of loop 2 because they think that last step is part of loop 1.
No, so this one is the equation for loop 2 and this one is the equation for loop 1, right?
Yes, sir.
And in terms of whenever we are considering the loop 1, we are going from here, here, here and here. This is loop 1. Loop 2 is going that direction, right?
Yes, sir.
Meaning you are going along I2, so negative, and here rise, but there is another current. You are going this direction and I1 is in the opposite direction. So if I say for this one, I1 is here, right? For this one, I1 is here. And for that one, you have I2 here, and you have I2 here as well. Clear?
Yes, sir.
Is it clear now?
Yes, sir.
So now tell me what are the values you get here? Still there will be some confusion. Please redo it yourself, because everything will not be that clear. You need to practice, and you need to do mistakes. Otherwise, you are not going to learn. Okay? You will do it. You will get some answer that is wrong answer. Do it again. Scratch it and do it again. Don't try to erase your pencil and kick the pencils out, so long as it is not a drawing class, right? Okay, so you have here, what is that one?
75.
75 I1 negative plus 35 I2, and here you have 35 minus 35 I2, and 35 I1 plus 20 equal to 0. So you need to solve those and you can find out the value of I1 and I2, right? Clear? Can someone tell me what is I1 and what is I2 quickly? Quickly. So let's put it like that. I2 is 75 divided by 35
I1.
I1, that is 15 by 7 I1. Here, so this we get it from here.
Yes.
And from there what we getting? So we can say I2. So meaning 35 I1 minus 35 I2 is 75 divided by 35 I1 plus 20 equal to 0, right? This one goes. So 35 minus 75 minus 40 I1 plus 20 equal to 0. I1 is 0.5 ampere, and I2
is equal to 1.07.
So you said 15 by 7 times 0.5. 1.071, right? 1.071 ampere. So you got I1 and I2. I think you can see it. Clear? So you get I1 and I2, but we are not yet done. We need to find out. Okay, in order to find out, once we do that, then simply you can draw the equivalent circuit and you can find it out, right? Yes. And tell me step 3. We need to, no, we are still in step 2. Okay, for the step 2 we need to draw the circuit again.
Wat het hy gesê
We
is
need to draw the
aanvulling?
circuit again, clean
Wat
circuit.
sien? I1 of I2?
We need
Ek
a
het nie gesien wat of hy aangevang
clean
het.
circuit here.
Op haar laaste oukie.
I1 is 0,5 en
And
I2
doesn't
is
matter what is
1,07.
sitting there. Doesn't matter what is sitting there. What
Wat
we are
doen hy
interested in
beteken? Hy het
this
gelyktydige
is 30,
bewerking gebruik om
This is
die
10.
twee veranderlikes gehad.
this is 20, and this one is 15, right? Here we have I1. Here we have I1. And here we have I2, right? Okay? Why I am saying that? Because I want to walk along this direction. So this point was B. So this was B, and this point was D. We need to find out B, D. Clear? So meaning, now start from here. Start from here. So 30 dB equal how much? Minus 30 I1 right? Minus 15 I1 plus 15 I2, clear? Now you are going from there to there. So VBD, you are going up, that is plus VBD, so equal to 0. Meaning, we are showing this is your VBD. Clear? Meaning, here to here, negative to positive. Okay? So we are assuming B is at higher potential. VBD means V of B with respect to D. We are assuming B is higher potential than D. If it is negative, we will say the other way around. Clear?
Yes, sir.
So, we are getting minus 45 I1 plus 15 I2 plus VBD equal to 0. What is the value of VBD? Quickly. VBD equal to 45 times I1 was what? 0.5, right? Minus 15 times 1.071. What is that? 6.45. Is it still positive? 6.435 volt. Right? I am not sure whether we did any calculation mistakes or not, but yeah, we got this one. So that was the one equation, and we get from there to there, and then we get this one. Okay, and this is the answer we are getting. So, third step would be something like that. You remember what we said. This is Thevenin. This is Thevenin, right?
So this is set 3 now, sir.
Yes, last one. And this one is B, and this one is T, and there is a load resistance. What was the load resistance, you remember? What was the load? 40? RL was 40. Thevenin is 6.435. And Thevenin was how much? 16.071, right? So the current here, which will be the answer here, IL equal to how much? IL would be Thevenin. This formula is always the same formula, Thevenin plus RL, right? So 6.435 divided by 16.071 plus 40. So what is the value? 6.435 divided by 16.071 plus 40. Is it 0.1148 kind of ampere? Is it that? Now you are going to redo that yourself. You are going to do the problem by Kirchhoff's KCL and KVL, and you see whether it is the same result or not.
But I think for the values for I1 and I2 today.
I need that attendance papers. Where are those?